Welcome to cis370, Introduction to Networking. In this lesson, we talk about network topology. This lesson describes designs for connecting computers. Designing a network topology. Network topology refers to the arrangement or physical layout of computers, cables, and other components on the network. A network's topology affects its capabilities. The choice of one topology over another will have an impact on the type of equipment the network needs, capabilities of the equipment, growth of the network, way the network is managed. Topology can also determine how computers communicate on the network. Different topologies require different communication methods, and this method has a great influence on the network. Wireless networks connect computers without using cable. Most wireless networks actually consist of wireless components communicating with a network that uses the cabling, a mixed component network called a hybrid network. Standard topologies. All network designs stem from four basic topologies. Bus. A bus topology consists of devices connected to a common shared cable. Star. Connecting computers to cable segments that branch out from a single point or hub is referred to as setting up a star topology. Ring. Connecting computers to a cable that forms a loop is referred to as setting up a ring topology. Mesh. A mesh topology connects all computers in a network to each other with separate cables. This is the bus topology. Bus topology consists of a single cable called a trunk, also called a backbone or segment, that connects all of the computers in the network in a single line. For bus topology to send in the signal, network data in the form of electronic signals is sent to all the computers on the network. Only the computer whose address matches the address encoded in the original signal accept the information. All other computers reject data. So every computer's network interface card has the hardware address, and these addresses are unique for each NIC card, network interface card. This is called MAC address. Computers on a bus either transmit data to other computers on the network or listen for data from other computers on the network. At the very end of the bus topology, a terminator, special terminator, is needed. The purpose of the terminator is to absorb the echo. A break in the cable, all network activity will stop in the bus topology. The computers on the down segment will attempt to establish a connection. While they do so, workstation performance will be slower. A component called a barrel connector can connect two pieces of cable together to make a longer piece of cable. This is an example of a 10^2 BNC connector. We use a barrel connector to connect two segments together. Using too many connectors can prevent the signal from being correctly received. So there is a longest limit. A device called a repeater can be used to connect two cables. A repeater actually boosts the signal before it sends the signal on its way. A repeater allows a signal to travel farther and still correctly received. Let's talk about star topology. In the star topology, cable segments from each computer are connected to a centralized component called a hub. Signals are transmitted from the sending computer through the hub to all computers on the network. The star network offers the advantage of centralized resources and management. This requires a great deal of cable in a large network installation. If the hub fails, the entire network goes down. Ring topology. The ring topology connects computers on a single circle of cable. There are no terminated ends. The signal travels around the loop in one direction and passes through each computer, which can act as a repeater to boost the signal and send it on to the next computer. So ring topology, signal get into one computer and each computer repeats the signal to the next one. It's not kind of broadcast as in the bus topology. One method of transmitting data around a ring is called token passing. The token is passed from computer to computer until it gets to a computer that has data to send. This is the way to regulate who can talk. Only the computer has the token can send the data, and a token is a special series of bits that travels around a token ring network. Each network has only one token. The data passes by each computer until it finds the one with an address that matches the address on the data. The receiving computer returns a message to the sending computer indicating that the data has been received. After verification, the sending computer creates a new token and releases it on the network. The token circulates within the ring until a workstation needs it to send the data. Mesh topology. In a mesh topology, each computer is connected to every other computer by separate cabling. This offers superior redundancy and reliability. Often, a mesh topology will be used in conjunction with other topologies to form a hybrid topology. Hubs. One network component that has become standard equipment in the network is a hub. Active hubs regenerate and retransmit signals in the same way as a repeater does. Active hub needs power source. They act as connection point and do not amplify or regenerate the signal. Hybrid hubs. Advanced hubs that will accommodate several different types of cables are called hybrid hubs. Hub considerations. Hub-based systems are versatile and offer several advantages over systems that do not use hubs. Hub-based topology includes the following benefits. Wiring systems can be changed or expanded as needed. Different ports can be used to accommodate a variety of cabling types. Monitoring of network activity and traffic can be centralized. Variations. Star bus. The star bus is a combination of the bus and the star topology. If one computer goes down, it will not affect the rest of the network. Star ring. In the star ring, the ring is centered in a hub that contains the actual ring, such as IBM token ring. The physical connection looks like a star, but the ring happens inside the main hub.